Okay, so this is about take 4. Me, in my infinite wisdom, I took the recommendation of somebody else and bought a microphone. But every time I plug this useless, unmentionable item in, Google Assistant says, "Hey, can I help you?" and promptly interprets everything I say to be a Zoom command, and I end up looking at this little tiny key all the way over here. Okay, that's the rant over. I apologise if the sound's a little substandard, but I'm really sick of doing multiple takes on this. So, some of you have seen this item here and you're probably salivating, some of you are not, others are going, why do we care? Well, this is an Amstrad 128K colour personal computer, or a CPC6128, assuming that CPC stands for colour personal computer. Now, part of what came with this was, or should have come with this, is an external 5¼ inch floppy drive, but I'm told that floodwaters took its life by this much and this only just barely survived. I'm also told the keyboard might not work. This hasn't been powered up since the 80s, so it'll be interesting to see what happens. I'm expecting some kind of catastrophe with the high tension capacitors in the CRT supply, so we'll see what happens. But let's have a quick look around this. Let's turn it around and have a look at the rear. So we have edge connectors much the same as a VIC-20 and the Commodore 64s. We have for a second disk drive, a monitor, a 5V DC and a 12V. Now, we have a male plug for this, for the 12V, and a female for the 5V. And we have this marked as a 5V and a male plug. I assume this is just so that you can't get them the wrong way around, but it does lead to the uneducated impression that maybe the monitor's supplying 5V or something crazy. So in either case, I'm guessing we'll discover that anyway. Look, to be honest, I would probably do something like this myself to prevent catastrophic hiccups like 12V on the 5V line. Anyway, we have our power, we have our volume, which tells me it has some sound, and I think over in the corner here I can see a little speaker. So I wonder how advanced that sound's going to be. Not much is my guess. There is a printer port here, and there's also an expansion slot. I think that could be almost for cartridges, I don't know. The other thing that came with this is a stack of specialty floppies. These are specific to this unit by the looks. In addition to those, I got the whole manual, which I've had a brief read of, and it seems to use BASIC. It's a very similar BASIC to the 6502, but I believe it's a 6128 BASIC. But yes, we'll get more into that as I read more of the book and I'm more specific about what I'm actually blabbing on about here. So let's get on to the smoke test. Let's see if this thing actually fires up and does anything. So I hope this angle is not too bad for you. I'll turn off my extraction in the background and you'll be able to hear my apprentice watching our shows in the background, no doubt. So let's smoke test. Well, no loud bangs or crunches. Let's turn our screen on. Okay, I don't see anything yet. Let's try the power switch here. Nothing, so I don't appear to have power at all. Let's just double check that this is actually in the on position. It is indeed. That appears to be depressed, and our mains does appear to be connected. So let's see if there's any brightness, but I don't even see a power light here. So let's turn off our overhead lights. Okay, we have backlight, and the brightness does appear to work. Contrast. Okay, so we have vertical holder, so our screen may be functional. Let's see what we get. Alright, this warrants some further investigation. Okay, so we know that the monitor works. So let's see if we've got some power. This is a little nifty gadget I made for testing CCTV camera power supplies. Now, I have checked off camera with a multimeter to make sure that this is actually an outer negative, center positive. So let's check this guy. We'll see. So we happen to have a 5.19 volts on that line. Let's check our other line over here. Let's see what we get. Well, I'm not seeing anything on that, though we could have the wrong plug. It's all the way in. So it looks like we have no 12 volt, which is interesting. We may be able to substitute that, given that this system's got a common ground. Alright, let's do some more experimenting off camera, but it looks like it might be just the 12 volt line that's not doing the job. Okay, so let's just recap where we're at now. I have a couple of banana plugs in my 12 volt output and a couple in the 5. Now I happen to have a 5.5 2.1mm connector already wired with banana plugs, and that is connected to the 5 volt input. And yes, before you whinge, I have checked the polarity. Now, this is the 12 volt input. This looks unwholesomely dodgy, but I'm just testing. This is the 12 volt line, and you see center is positive, outer is negative. I've confirmed that on both ends. So let's see if it's just a 12 volt supply. I have the monitor plugged in. I'm going to power up the monitor, but that also means that I can have the monitor powered and I can hear the squeal. You might not through this. The monitor can be powered up, but I'm not going to worry about any ground faults, which I probably shouldn't anyway, being as it's a double insulated device. There is no mains earth to that. Alright, so let's go over here and we will go 5 and 12 volts. Whoa, okay. The lights dimmed, which was a good indication that there's a dead short somewhere. So I think what may have happened is there's a power supply fuse gone. So I'm going to grab my multimeter and check that now for a dead short. That could be a diode, I believe, but we'll find out. Okay, so we're back at the junction box again. For those of you who haven't watched my other videos, this was a custom-made box that I've designed. This output down here is for continuity. I'm going to disconnect the 12 volt line because that is piggybacked off a 9 volt regulator. When I touch these, I get continuity. So let's spin you around like a merry-go-round, and we'll go back here and adjust my tripod. Whoa, this is interesting. So these probes I've made a smidgen short, but let's go ground here and we'll see what we get coming through. So, whoa, that didn't like that. There is a little bit of feedback from something, even though all of this is isolated. This is why I put fuses on things. And keep in mind that is fed off a 7809. So there's only so much current it can supply. So let's try again. Let's go. Alright, so there's no continuity. Well, let's have a look here. So we have no continuity across there. That is interesting. Nothing at all. Now I'm going to have to go back over here, but I may have been checking this one, which would make sense why that was a dead short. That's straight back into that panel. But in any case, that's what fuses are for when you're testing. So, alright. There may be a ground loop between the two. In either case, I think what we need to do is actually open up this and see what's going on inside. I'm just checking to see if the monitor still has some life. Apparently it does. Okay, so actually let's go to minimum running lights here and see with a different color spectrum. Yeah, that looks alright. Okay, let's open this up and see what's going on inside. Now I apologise for the background noise here. It's probably a symptom of the microphone unit. I just wanted to point out something here. The string that was holding this together is actually dial cord. And given that the previous owner to this used to work with radar and radio and various other things, I'm really not surprised to find dial cord holding everything together. These days, genuine dial cord's getting a little hard to find for doing the vintage radio stuff. I just thought that was an interesting footnote. Okay, so I've had to engage some medical cooling in the background. I lost the feeling in my knee, so yay for MS, I guess. So this is the 12 volt line in here. Going to start with the very, very basic and just check if the lead itself has proper continuity. So I'll take these little critters over here. Oh, we're going to hear that that works. Let's check our ground connection. So here we go. I've got one on the ground under my thumb here, one into black lead, no continuity to the other side. Let's check our hot wire, nothing on negative. Alright, so it looks like we have continuity. So let's try across these two. Nothing here. Swap our polarity and check. Now, concerningly, I don't see anything that resembles any kind of a fuse in here. And directly behind the 12 volt lines, there's a couple of transistors that would be very easily damaged. So I think I'm going to take some time and just inspect this very carefully and see if there's anything really obvious that I can see. Okay, well, there's a little interesting thing I've discovered, which I think was causing the problem. If I try and do continuity across the ground here, unlike a modern computer, the grounds don't connect. I'm touching let's do it from the other side here. You can see me touching the shield of the 5 volt input and the shield on the 12 volt input. The grounds are not connected. However, if I take the positive 12 volt, we have continuity to the shield of the 5 volt. So it's a little bit like a guitar amp where they have a push-pull power supply. So they're pushing 5 volts in reference to ground and 12 volts in the opposite direction. So when I try to supply these off the same power supply with a common ground, I'm essentially getting a dead short. The plus about that is that I probably haven't killed the board, which was a slight concern. But again, it just proves you can't make assumptions about these things. So we might still be okay. However, what this does mean is that short of me getting a 7912 regulator, which I don't have, or a 7915 regulator, and rebuilding my whole supply board, I'm probably not going to be able to come up with a power supply. So I'm going to have to look inside the monitor and find out what's on with the power supply in there. The plus side is I can't see any burnt components. There isn't a short across here. It's just because it's a push-pull supply. And it doesn't look to be particularly dirty. None of these capacitors seem to be bulging. I hope that's pre-capacitor plague era capacitors. Doesn't mean they're not dead, but it means they're a lot less likely to be. This floppy drive looks to be immaculately clean, and we'll go over that in detail a little bit later once we get this working. For those of you unfamiliar with CRT monitors, the high tension side is right here. This, and judging by the fact that the dust is all standing off, this tells me that that capacitor is still probably quite hot. I'm going to pick a screwdriver that I don't use so much to do this, and note I'm keeping quite careful thing. We're going to discharge this capacitor if I can get under this, because that will give me a bite that I won't forget. and might make for some comedic footage, but I don't really want to be the actor in that. And this is on quite well. I don't want to scratch anything here, but I do need to really discharge that capacitor. Here we go, we're underneath. It should be a loud crack if this is right. Well, there was a bit of a clack there. All right. Yeah, okay. I'm going to be careful nonetheless because I can see a very big one up there. So let's have a look. Now, really interestingly, there's this power transformer that's floating around loose in the top. That's a really fun way of doing things. So this is an Orion monitor, very much like a TV, but I'm noticing there's some interesting little anomalies in here, probably for the 12 volt supply, which if we tip this up carefully, we can see it belongs down in this bottom corner here. So let's spin this around carefully and have a look at where our 12 volts comes in. Alright, so let's check. Alright, actually this could be quite easy. So let's have a look here. This little daughter board here is a little regulator, and that looks like it's an LM7812 or an old version of it. I have a few of those. I think if there's anything wrong with the 12 volt, that will be it. So I'm going to test that and see what happens. Okay, we have the 12 volt regulator out, which is its own little board with a plug. I like it when people think that things might need to be repaired. It looks like there were some intentions of having a significantly larger amount of filtering on this, and they've just gone with a flat out LM7812. So I'm just going to pull that heatsink off the board and that regulator and replace it and see what happens. I guess I could feed, I'd have to feed more than 12 volts into that and see what comes out, but you know what, I think I'm just going to replace it and see what happens. I can't really do any harm with that, and I happen to have my, on loan still, my super noisy desoldering tool. So let's get started with that. Okay, we have smoke test time. I have my little inline voltmeter hooked up in the socket on the front here, and I have a mosquito hanging around the front of my face right now. This is the board, or up here, this is the board we have just replaced that LM7812, the 12 volt linear regulator. It's hanging around over here, in fact. And this may or may not be the problem, but this little critter here, basically you hook ground up to it and you do volts in, volts out, and it brings it back down to 12 volts from usually anything up to around 28 volts in. You do need to, because it's a semiconductor and a linear regulator, you usually need about 12 volts, 2 volts or so more than your output voltage. So in this case, it would be expecting at least 14 volts in there. It could be much higher. I don't really want to play with this. Anyway, I have this hooked up to the mains voltage. I'm going to turn it on first at the monitor. Okay, now I do have an RCD connected here, and in Australia we use 240 volts. So an RCD or a residual current device might not save me if I stick my nose in the board. So let's turn this on, and I'm going to close my eyes. Alright, I can hear the screen on, but I still can't see 12 volts out. Okay, we have probably a problem on the supply side, so let's turn this off. And that high-pitched squeal has gone away. Okay, so we've got a problem further up the chain. So I'm going to need to disconnect this from mains. And of course now that main filter capacitor is charged. So it's now made this board dangerous. So sadly that didn't fix the problem. Let's go and see what else is wrong. Okay, so I thought I want to see what's coming into this board. So I've made myself up a little adapter just out of a 2 pins off a little pin header that I had floating around, and I've cut up a couple of clip leads. It's not like I'm running short on them since I cleaned up. So yeah, let's have a look at how this goes voltage wise. Okay, I'm going to get you guys to just keep an eye on the multimeter for me. If you can see what's going on. Currently it's not powered or turned on. I'm seeing 0.5 volts on there, or it was originally 0.6. Let's just turn the monitor on. That tells me there's a capacitor bleeding down somewhere. Alright, I've got the monitor turned off. About to turn on the mains. Okay, so let's turn the monitor on and see what happens. Alright, we go over limit. That's not good. Okay, so maybe this is over voltaging things a bit. Let's move up to the 200 volt range and reposition this so we can see what's going on. How's that look? Alright, let's try again. Let's just turn the monitor on here. Okay, so we've got about 20 volts coming in. Well, that's pretty good. And the polarity's right. So why don't we have voltage out? Could be a socket, but I did reflow the connections. It could be a capacitor. That could be it, but let's... This is going to be frustrating, but we do seem to have a fairly solid, stable 20 volts out, which, as I explained before, is well above the 2 volts of the output, so that should be perfectly fine, and it's quite stable. We're not fluctuating at all. So the problem is going to be in that one last component, which is that capacitor. I don't think I've got one handy, but we'll see. The one problem I'm going to have is that the J-car dealership in town is changing hands, and I'm going to have to talk to and maybe educate the new guy. Okay, we have one last voltage to check here. I have this connected up to a 5.5 2.1mm socket into the front of it, and I've got it in a high voltage range. So we're just going to see what's happening here. Let's turn our monitor back on. Where are we? This should be reading 12 volts if everything's working fine. And we have minus 11.9. Okay, so what have I done wrong here? That isn't a 7912, because the 79 series regulate the negative side. So we have a negative. That's not right. Although it wouldn't be regulating, so we are getting 12 volts out. That would explain why my little voltmeter is not reading. It's a reverse polarity. The plot thickens. I think I need to look up some specs before I plug any of this back in. Well, I did some thinking and I did some research and traced some boards. And actually, this one really is centered negative. That's actually the way it's meant to be. That explains a lot for my short circuits earlier. But more importantly, we turn this on, we have a red power light. I'm really happy, and we have something here, which I think if I mess with vertical hold, we actually have a working Amstrad. Really, really good. So I'm going to put the screws back in this, and we'll go from there. I'm really happy to see this. It's alive again. Okay. It's time to try a disc, and that's a disc 2. Let's go through this pile and just see what we have. that has a whole lot of stuff on it. I don't know the first thing on how to actually run one of these, so I'm looking for something that might run at boot. Should probably notice at this point I've already put together the extra screws. That's CPM Plus and System Utilities. Let's just start with that. Now let's turn this on. Where are we? There's a thingy-mabob here. Oh, interesting. Let's turn you off. It was running before and I had a picture on the screen. That appears to be the on. Let's try now. Oh dear, okay. Let's see what's going on here. I did have to unplug everything. I wonder if it has failed again. I did have a keyboard up. I need to investigate. Okay, I had a quick wriggle of some leads, and that's what we had. Now, I think the shield is this little metal thing here. And these are compact floppy disks, CF2s. I have never seen these before, but let's see if we can make a hash of this. Guess that's the way it goes in. They appear to be double-sided. Okay, now let's just check. Really, I can't get a video out to get a video capture, so I'm really sorry if this is some unsynchronized, difficult to read stuff. But let's check the keyboard here. Okay, that seems to be working quite well. Okay. Okay, the keyboard seems to be working quite well, and sounds like the sound is working just fine as well. At this point, other than knowing a few little basic commands, I don't know how to run things off the disk. So I'm going to have a quick read of that book and see if we can get something happening just to entertain you guys. Alrighty then, I've done myself a little bit of homework, and geez, I wish computers booted up this quick these days. Alright, and sorry about the screen flickering here. We're going to load a disk. I've picked one at random here that says it's a dev pack editor assembler disassembler. In either case, we want to see if we can run a disk. So let's have a look here, and let's load cat. Should load the contents of the disk. Okay, I'm not sure if we need caps lock here, but the tutorial calls for it. We're going to go run with quotation marks, and let's try disk, D-I-S, and they spell disk with a C, not disk with a K. So yeah, not sure how that came about. I guess we'll find out at some point. And we're loading a basic file, so .bas. Let's run that. We've got some disk activity. Here we go. So we're loading an address. I'm not sure actually what to do with this, but let's just say address 1. So loading Mona now. Okay, I guess let's do that. Load the address for Mona. Let's try 2. Don't know what I'm doing, but I've apparently filled up the memory. All 128K, but I think there's actually not all that much left. I think I read in the book that there's somewhere around about 40 or 48K left after the OS consumes it. So let's turn this off and spit our disk and turn it back on again. And we'll pick another disk at random and see what we get in here. What's this one? This has IPCM and some other things in here. Hoping there's no personal files that we might inadvertently reveal here, but not a lot we can do about it. Let's try a cat again. Oh, we've got AMS-DOS, palette flip profile rename, show type. Oh, interesting stuff. Erase keys. I think I'll stay away from the erase one. Don't know, guys. What are we going to do? Bankman. That sounds like a bank manager. Let's try that. So let's go run bankman.baz. I've got to say, I quite like the feel of this keyboard. I wish keyboards these days were like this. It's beautiful. I can type quite quickly. I know that I've pushed a key, and it flows fairly nicely. So I've run bankman.baz, but nothing really appears to have happened. So, and also, crucially, like modern command lines, the up arrow doesn't retrieve the last command, so you have to retype it. Some of you experts out there will probably tell me that there is another way to do that. Let's see if we can run set.com. I hear the disk moving. Line is too long. Well, okay, at least we're loading it right. Let's try type.com. I'm determined to get something semi-useful happening with this, so we can see what's going on here. This is mostly me. Line does not exist. Okay, so I'm going to try one more, then we'll try a different disk. Let's try show.com. I assume that means command. Okay, I'm guessing .com is short for command, and that's probably analogous to batch scripts, I assume. So let's have a look here, see what else we get. That little chiming sound as my phone desperately going flat. Alright, we've got another card here. Oh, this one has a little card inside telling us what's on here. Reversey.c. Oh, that could be interesting if that's actually a game. So, it may not be. Let's see what we have. Oh, there's a little bit on this disk. Looks like some backups and walks. These look like files that might be associated with some sort of editor, but there's a disk.baz on there. Hello.com. Head.me. Oh, there's a few things. Let's try reversey.com. Let's have a look here. See what this does. Line's too long. Alright, so I'm clearly missing something here. Let's try a basic file. Let's try disk. Whoa, slow down. It'd be nice to actually hear it do something with the sound. But I get the feeling it probably doesn't have a great audible library in here. Oh, hello. HiSoft C++ compiler. This side of the disk contains the CPM compiler hc.com. To use it, you must first start up CPM by putting in your CPM master system disk into the drive using the CPM command. Okay, and that's from Dave Houseworth in 3rd of October 1985. Alright, well, we've got some function out of this and it's actually working, so I'm going to consult with a book, and over some time I'm going to call this a video and we'll do some more later. So yeah, I like this stuff. It's a syntax error, we thought about that. Alright, thanks for watching this video, and I guess we'll do another one when we find something more interesting to do with this.